Welcome to Two Projects. In this video, we are going to explain the project on the performance of deep transfer learning networks for brain tumor detection using MR images. Before diving into the execution, let me give you an overview of the project. So, this project focuses on using deep transfer learning networks to detect brain tumors from MRI images. So, brain tumors, which can be benign or malignant, need early and accurate detection for effective treatment. But traditional methods of doing this, like MRI scans and biopsies, are time consuming and can be prone to human error, making automated and reliable systems essential. And manual examination of MRI images varies between radiologists, leading to possible misdiagnosis and subjectivity. And traditional machine learning methods also struggle with the complexity of MRI images. That is why this project proposes to use models like ResNet 50 and VGG16 combined with techniques like SVM, decision tree, and random forest. The workflow includes importing data, pre-processing images, visualizing data, splitting the data into training and testing sets, building different models and evaluating their performances to select the best performing one. The overall goal is to develop a robust system that helps radiologists detect brain tumors more accurately and efficiently, ultimately benefiting medical practitioners and patients by improving diagnosis and treatment outcomes. So, this is what happens in this project. This is the overview. Now we look at the software and hardware requirements. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, back-end framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So these are the algorithms built ResNet 50, VGG16, and these hybrid models. So these three models use ResNet 50 for feature extraction, and the features extracted from ResNet 50 are inputted into these machine learning models, SVM, decision tree, and random forest to get the detections. Similarly, these three hybrid models use VGG16 for feature extraction, and the features extracted from VGG16 are inputted into SVM, decision tree, and random forest for detection. So these are the algorithms built. We have trained these algorithms and we have evaluated their performances using different performance metrics like accuracy, precision, recall, and F1 score. And we have observed that VGG16 has outperformed all of the models in all the performance metrics. So we have deployed VGG16 into the Flask framework. So we will be executing the project using Flask web application. Before execution, first, we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is data folder. So in this folder, I have two subfolders, no and yes, indicating the presence or absence of tumors. So in yes folder, I have these brain MRI images indicating the presence of tumor. Similarly, in no folder, I have these brain images indicating the absence of tumor. So before training the models on these images from these two folders, we will split this data set into two subsets, training and validation sets. So we'll combine them and split them into two subsets. Train set is for training the models and validation set is for evaluating the trained model's performance. So after doing that, after splitting the dataset into training and testing sets, we have stored that dataset in this folder. So now 80% of the data from no and yes folders is into training set. So this data is used for training the models, and 20% of the data from no and yes folders is into testing set. This data is used for evaluating the trained model's performance. So this is about the data set, and these are model folders. So these folders contain model files. So these model files contain algorithm information which will be loaded into the project code during runtime to utilize the trained models. This is static folder which consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is test images folder in which I have test cases which will be used during the execution of the project. This is app.py file. So this .py file contains the information related to front-end logic. It includes code data in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. It stores information like user signup details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path of the code folder and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the Flask framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see a sign up link, click on it. So if we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have account, we can directly log in by clicking on this link. As I am already a member, I am clicking on the sign in link. Here we have to give our credentials, username and password. I'm giving mine and click on submit button. So it has redirected us to the detection page. So now we have to upload brain MRI images here and the application will detect the presence or absence of brain tumor from the MRI image. So here we can see we have to upload files less than 500 KB in size. Now click on choose file button. So from test images, these are the test cases I have. So I'm selecting this image, select the image and click on open. The image has been loaded. Now click on upload button. So this is the uploaded brain MRI image. And here we can see the outcome, that is you don't have tumor based on the input MRI image. So the application has detected the absence of tumor. That means this person is not having brain tumor, which was observed from the MRI image uploaded. Click on try again link. We'll try uploading another image. Click on choose file. This time we'll try uploading the second image. Select the image and click on open. The image has been loaded. Now click on upload button. So this is the uploaded image, and here we can see this is segmented image based on threshold. So this is an image where pixels are divided into tumor and non-tumor regions based on intensity levels. So this part is the tumor detected area. This is segmented image based on morphology. So it is an enhanced image using techniques to clean up and improve the segmented tumor region. This is the tumor region. And this is final image with contours. So here we can see the MRI scan with outlines drawn around detected tumors showing their exact boundaries. So we can see the outlines here. So these are all tumors. And here we can see the outcome, that is you have a tumor based on the input MRI image. So the application has detected the brain tumor from the MRI image uploaded, and if the brain tumor is detected, it will give us these images. Now click on try again button. We'll try uploading another image. Click on choose file. We'll try with the third image. Select the image and click on open and click on upload. This is the uploaded MRI image. This is the segmented image based on threshold. This is the tumor area. This is segmented image based on morphology. And this is final image with contours. We can see the outline drawn around the tumor area. And here we can see the outcome, that is you have a tumor based on the input MRI image. So the application has correctly detected the presence of brain tumor from the MRI image uploaded. Click on try again, click on choose file. Now we'll try with this image. Select the image and click on open and click on upload button. So this is the uploaded image, and here we can see the outcome, that is you don't have tumor based on the input MRI image. So we can see the application did not detect the brain tumor from this MRI image. So this person is healthy. Click on try again, click on choose file. We'll try with this image. This is the uploaded image, the brain MRI image. Here we can see you don't have tumor based on the input MRI image. So the application has detected the absence of brain tumor from the MRI image uploaded. Click on try again, click on choose file. We'll try with this one. This is the uploaded brain MRI image. This is segmented image based on threshold. This is the tumor area. This is segmented image based on morphology. And this is final image with contours. We can see the outline drawn around the detected brain tumor area. And here we can see the result, that is you have a tumor based on the input MRI image. So in this way we can upload any brain MRI image and can get the detections whether the person is having brain tumor or not. We'll try with one last image. Click on choose file. We'll try with this one. Select the image and click on upload button. This is the uploaded image, and here we can see. So this person is not having brain tumor. So we can see you don't have brain tumor based on the input MRI image. This is the outcome. Now we look at the graphs plotted. Click on the graphs link here. Here we can view all the visualizations made. So here we are displaying sample images of all classes, yes, no. So these are sample brain MRI images. This is class distribution graph. So in this graph on x-axis, I have labels, that is the classes, no and yes, and on y-axis, I have their counts. This is comparison of models graph. So in this graph, blue line, blue color bar represents accuracy, Orange color bar represents recall, green color bar represents precision, and red color bar represents F1 score. So we can see VGG16 is doing well in all the performance metrics. And these are individual graphs of all the models. This is accuracy score comparison graph. This is recall score comparison graph. This is precision scores comparison graph. And this is F1 scores comparison graph. So these are the graphs plotted. Now click on logout. So this project shows that deep transfer learning networks can accurately detect brain tumors from MRI images, enhancing diagnostic efficiency and reliability. The developed models assist radiologists by reducing human error and enabling early diagnosis, ultimately improving treatment outcomes and patient care.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.